Big data is a term used to describe extremely large datasets, so large that traditional data processing systems can't deal with them. They may be so large that they need to be stored across multiple disks, attached to multiple computers in a cluster, and new data can be coming in at a high rate. In fact, one definition talks about the 3 V's of big data as being volume, velocity, and variety. A large amount of data, increasing rapidly, and being partly or completely unstructured. Global internet-scale companies, such as Google, Yahoo, Amazon, Facebook, are genuinely generating big data and attempting to analyze it to find ways to extract value, whether that is by showing their users adverts that are more likely to be relevant to that user, or products that they are more likely to buy, or news stories that they are more likely to be interested in. Many other companies, whether working at this scale or not, would like to apply the same methods to better understand their problems and their customers, and provide better solutions and services. The story of Apache Spark begins in 2003 when some researchers from Google published a paper called The Google File System, describing a way of storing very large datasets in a distributed way on disk. A second paper from Google in 2004 called MapReduce, Simplified Data Processing on Large Clusters, described a way of processing those stored datasets. And with that, the ingredients for big data processing were in the public domain. The next step in making it practical happened at Yahoo, where 2 engineers looking at improving their web indexing and search engine read those papers and ported their existing work to Google's architecture. Importantly, they also spun out their work on implementing Google's infrastructure as an open source project, now hosted by the Apache Software Foundation as Apache Hadoop. The distributed file system, implemented in the Hadoop project as HDFS, which stands for the Hadoop Distributed File System, not too surprisingly, continues to provide reliable, fault-tolerant storage for very large datasets. The MapReduce programming model, though, is a bit too restrictive. It was very important for getting the idea of general big data processing off the ground. But for most specific cases of data processing, you can do better, go faster, and express your idea more clearly with a more flexible programming model. Apache Spark is an engine for cluster computation like MapReduce, but instead of focusing on map and reduced steps in data processing, Spark allows for the construction of more general pipelines of data transformation and combination. It was originally developed at the AMP lab at the University of California, Berkeley, open-sourced in 2010, and was donated to the Apache Software Foundation in 2013, where it is hosted to this day. It interoperates with other Apache projects, most obviously Hadoop, which provides the Yarn application management framework, as well as HDFS, and external data. In this course, you'll learn about using Spark with datasets hosted on Amazon's Simple Storage Service S3 platform. Spark is mostly implemented in Scala, a programming language which emphasizes functional as well as object-oriented programming, and which interoperates well with Java and runs on the Java virtual machine. Although the most seamless way of working with Spark is to program in Scala yourself, in this course we'll be using a Python interface, which wraps all the Scala functionality and provides a Pythonic way of using the Spark engine. Spark works by taking the description of the data processing that needs to be done, the pipelines I referred to earlier, and firing off compute jobs to calculate the results of those pipelines when necessary. Don't worry about the details of that yet. We'll go into more detail in future lessons. What's important for now is that you know that there is a driver process which is responsible for communicating the work that needs to be done to executor nodes, which perform the work and report the results back to the driver. Spark can act as its own application manager on a single, standalone computer, or it can be used with Yarn to distribute those computations across a whole cluster. In this lesson, I've introduced Apache Spark and related it to other technologies in the Hadoop ecosystem for dealing with big data. The Spark programming model doesn't assume that you have big data in the terabytes or more. You can use Spark with more modest datasets, but it makes working with larger ones possible. Spark builds on the Hadoop distributed file system and the Yarn application management framework, both Hadoop subprojects, but allows a more flexible programming model than the basic MapReduce in Hadoop.